Hi, welcome to this edition of Tech Clarity TV. My name's Jim Brown, the president of Tech Clarity, where we make the business value of technology clear. Today I'm going to be talking to you about using 3D for virtual training in the industrial environment. Today I'll be sharing some of my research with you on using learning science and virtual reality to really take advantage of new opportunities for training in the industrial setting. First we'll start and we'll talk a little bit about some of the challenges of training in an industrial environment. We'll talk a little bit then about the science of learning. Don't worry, I'm not trying to give anybody a PhD in this. I don't have one myself. But then we'll talk about how 3D simulation can take advantage of that and how that's now more in reach for industrial companies than it ever has been before. And then I'll share some examples with you of how it's being used today. Let's talk about some of the challenges of training in industrial settings. First of all, those locations are not always going to be close to us. We may have employees that we're trying to train for a mine in a distant country or an oil rig that's out at sea. So simply transporting people there for training can be very expensive. But it can also be dangerous. It can pose a lot of risk to untrained workers to have them in certain settings. And if you think about certain scenarios we may want to train on, such as a fire in a mine or responding to some sort of a chemical spill or a problem in the core of a nuclear reactor, those are kinds of situations where we don't want to put people in harm's way in order to train them. And having an untrained worker in some of those environments could certainly put them in quite a bit of danger. But there's also some business implications to consider. For example, if you want to train people on equipment that's running 24/7, you need to take that equipment out of production. So it's not doing what it's intended to do to make money for your company, and instead you have to idle it in order to train people on it. So there's a lot of challenges that need to be met. One of the answers to this that companies have been using is simulation. I'm sure you're probably familiar with flight simulators and maybe some others. What they do is offer a bit of hands-on training. And that hands-on training, we'll see in just a moment, can provide a really good way to assimilate and be able to recall knowledge. But it also allows people to repeat multiple scenarios in a low-risk environment and also in a low-cost environment, at least from a transportation perspective. But what we'll find is that those simulators can cost almost as much as the original equipment itself. Some of them are extremely expensive and they're not portable. So we end up flying people around just to get to a simulator to do training as opposed to taking them out to the real environment. So there's some real challenges. Although physical simulators do a good job of training, there's some real business challenges in employing them. So why do simulators work so well for training? People learn better by doing. You probably know this from your own practical experience, but there's something called double loop learning, where you learn something and then you repeat it and you compare what you're doing to your mental image of what you're doing, and you get feedback, and that helps you actually sort of refine your learning over time. And that form of learning is very, very good for people. And what scientists have been able to find out through research is that you can actually get that kind of hands-on experience by using simulation. So physical tasks can actually be done in a virtual environment, and then that learning can be applied in the real environment. And there's very little loss in fidelity of that information as you move from a simulated environment to the real environment. So simulation gives us a way to do some really effective training and do it in a virtual environment. Now, unfortunately, as I mentioned before, physical simulators can be extremely expensive. So one of the things that's happened recently is that 3D virtual simulation has really started to become more accessible. These are technologies that really started in the defense industry, but then we've seen over the last decade or so a lot of investment by gaming companies, by software companies that make games. And they've developed engines for gaming and rendering and physics that really take a lot of the work, a lot of the sort of custom work out of developing a training environment. These kinds of things allow scenarios to be developed, scenarios to be played out, and what we need to do then is apply it to the industrial setting. And the nice thing is that these are now available for commodity hardware, so we don't need to spend as much potentially as we would have in the past on very expensive specialized equipment. So for example, if you've seen virtual reality be people with helmets on and gloves and motion control sensors, those things can be very effective, but they aren't necessary in order to get the training that companies need for industrial settings. So one of the challenges in an industrial setting is developing these scenarios. Now that we've got these engines that can help execute against them, how do we get a 3D virtual environment? Well, another good trend that's been going on is there's a lot more investment today by manufacturers and other industrial companies in 3D design. So they've got 3D models of their environment, or maybe they're doing some laser capture and capturing 3D models of their environment. And these can now be reused. And what that does is prevent the need to have 3D artists go out and recreate an environment, because you can instead reuse an asset. For example, you might have an oil rig with all of the complex pathways and piping and stairways that has already been modeled, and to have somebody create a 3D environment from scratch would be relatively expensive, when instead it already exists and can be applied to the learning environment. So one example of this is what the Royal Australian Navy did with a program called LAST. They used 3D virtual training and trained up some sailors on a process, a 12-step process, and then took them to the actual physical setting of the ship to see what they would do. What they found is that those that had gone through this simulation were very familiar with the environment when they got there, even though they'd never set foot on the ship before. And what they were able then to do is actually go through and be much more confident, find the items that they were intended to find, and in fact were able to do a 12-step process in about half the time that would have taken them had they gone through physical training. In an industrial setting, there are lots of opportunities to use 3D virtual training. For example, in the oil rig I talked about earlier, we could have scenarios where we learn pathways, but also learn to operate equipment. For example, if somebody needs to open or close a valve, the learning science tells us that if they go through an action, even if it's pushing a button on a computer as opposed to physically turning a valve, that can help spark that muscle memory and that double loop learning that we talked about earlier, to help them really retain that information and be able to execute it in the setting itself. I'd like to end with some key takeaways. First of all, 3D virtual training really offers some great opportunity to overcome the challenges that are just inherent to training in an industrial setting. They help companies reduce training costs, but also reduce risk and allow them to keep their equipment online so it can make them money. And when they do deploy their employees, they're trained up so they can do their job with quality and do it safely. Simulation offers a great opportunity to do this, but physical simulators have been expensive. So now, through the investment of the gaming industry, it's much more in reach for industrial companies. And if they can also apply some of their own 3D models, then they can avoid the cost of 3D artistry, both the cost and the time. And this is really an opportunity that is available, it's in use today. I shared a couple of examples before, but the time is really right now to start to explore this idea. So with that, I thank you for your time and attention. I hope we can continue the conversation. I look forward to hearing from you.